Good evening, everyone. I hope you are all doing great today. So, yesterday we had a solid start to understanding Ceph. We talked about what Ceph is, why it's needed, and how it gives us a unified platform for block, file, and object storage. We saw how Rados is the heart of CEPH, the core engine that handles all data placement and healing. And also in the finally, we looked at the real world use cases from cloud to telecom to AI and research. So today we are going to zoom into one of the most important components in CEPH, the monitors. The short form is also known as MONs. Or Mon. So hello everyone. So this is Ayaskanta Parida. Um, I'm a machine learning engineer at Sensfrx. So let's start with the about Ceph monitors or mon. So what are Ceph mons or monitors? Let's understand mons step by step, what they are and why they matter so much. So in simple words, a mon or a monitor is like the brain of the Ceph cluster. It doesn't store any actual data, but it keeps track of what's happening in the entire system. You can think of mons like managers or supervisors. Okay, so as they don't carry the heavy boxes like the here the OSD's job, but they make sure everyone is doing their job properly. So you can think just like a manager or a supervisor here to a monitor. So what does the mon do? So mons keep track of the cluster state, like which nodes are online, which OSDs are active, and what data is set. Also, they manage the cluster maps. These are specially files that describe the structure and health of the cluster. In the upcoming videos, I'll show you how you can see the health of the cluster or the Ceph cluster. It also handles the authentication using Cephex, meaning they manage login access and security between clients and servers. Every time a client or a daemon wants to do something, like you can say read or write data, so it first checks with a mon to get the latest map and rules. Then let's know about why mons are critical. So if there's a no mon quorum, the entire cluster goes into read-only mode. That means no one can change anything until the mons agree again. Okay. So mon are the like the traffic controller of CEPH. They don't move the data, but they control the flow and the rules. So if OSDs are like delivery trucks moving packages data. So you just try to understand like if we can say that OSD are the delivery trucks that moves the packages. Here we mean the data. Okay, so OSD are you can say they move the data. Okay, so mon are like the GPS system who keep on monitoring and that tells them where to go and if the roads are safe or not. So this the mons help. And also you remember this, even if CPH is storing petabytes of data and if your mons are down, your cluster is in trouble. So because nothing knows what to do next. So as it simply said that if mon is down, because if your monitor is down, then your cluster, the CPH cluster will be in the trouble. Because as usual, if how it can be know where the data will be go or how where to go who, the data will be stored where, everything is being monitored by CPH. So sorry, the CPH monitors. So the Ceph mon or the monitors are very crucial. We have to always check that the monitor should not be down, it should be always up. Okay. So next, we see the next that the what are the different kind of maps that are managed by the Ceph monitors. All right. So let's go a bit deeper and see what monitors actually manage behind the scenes. Okay. So we just learned that mons don't store data; they manage maps. But what kind of maps are we talking about? In CPH, a map is like a document or a report that tells you what happening in one part of the cluster. Okay. So you just imagine like you are managing a big warehouse. You need maps or logs to track them. So like which shelves have space, then which workers are in or online, what items are where, and, like what machines are active. So that exactly what mons do for CPH. So as you can see in this table, these are the six major main maps mons manager. Okay, not manager, sorry, these are the main maps that mons manage. Mons means monitors manage. So one is mon map, that is monitor map, then is the OSD map, that is then is the MGR map. Map means manager map. Then is the MDS map, that is metadata servers map. Then is PG map. PG map means placement groups map. Then is the CRUS map. So mon map keeps a list of all active mons and who's in control. Okay, its function. So then OSD. So OSD map tracks which OSDs are up and down or in and out under health or status info. Okay. Then the manager map or MGR map shows which manager diamonds are active and their statuses. Then the MDS map. So MDS map is used only if you are using CephFS. That CephFS means CPH file systems, and it handles file system metadata servers. Then the PG map, the placement group maps. It tracks the health of placement groups, whether it is clean, degraded, or recovering, etc. The three clean, degraded, and the recovering are the states, the placement group states. I'll be showing you on the video, and I'll show you in detail in the upcoming lecture series while I'm going to deploy. Um, then is the CRUS map. So the CRUS map defines rules for how and where data is placed across the cluster. Okay, so every time something changes, like a node going down or a new disk being added, so Ceph updates the map for that component. Each update increases a version number called an epost. Okay, epost. As you can see, it's an epost. The versioning helps all diamonds and client to stay in sync. So if something is out of date, it will reconnect to a mon and get the latest map automatically. So as I said, Ceph do everything automatically. Okay. So let's give me a quick summary to you. So basically, mons don't carry data; they carry knowledge about the cluster, and that knowledge is shared in the form of different type of maps. Okay, in the form of maps, constantly updated, distributed, and versioned. So in one line, if you can say that you just think of these maps like real-time dashboards for every piece of the cluster, and mons are the ones maintaining and distributing them. Okay, so next let's ready to dive into the next part, that is PAXOS and quorum, and how mons reach the agreement. Okay, So now let's talk about one of the most important jobs of Mons, how they agree on what true state of the cluster is. Imagine, you just imagine, try to imagine, imagine three people trying to decide where to eat. Okay. If they don't agree, no one moves. So, let me repeat it again. So you just imagine three people trying to decide where to eat. If they don't agree, no one moves. Okay. So Ceph Mons are the same. They use something called the PAXOS algorithm to reach consensus. So what is PAXOS? PAXOS is a fancy word for a distributed agreement system. It helps Mons to decide together what changed, is it correct, and should we update the map. If even if some Mons are slow or disconnected, Paxos makes sure the majority of the rules. What is quorum? So quorum means majority agreement among Mons. If you have three Mons, at least two must agree to make a change. So without quorum, Ceph says, wait, we can safely continue. Okay, sorry, we can't safely continue. Sorry, actually, due to form mistake. So without quorum, the Ceph can't be safely continued further. So quorum is required for safely proceed further. So the system goes into read-only mode to avoid data corruption. Okay. So for your knowledge, Ajab, you can see why PAXOS is necessary or why it matters. So this PAXOS ensures that only one true version of the map exists. Okay, only one true version. So then, as the split brain protection, let's know about it. So let's say two mons think one thing and two others disagree in a large cluster. So that's called a split brain, a dangerous situation where both sides think they are correct. Okay, so CPH prevents this by allowing updates only if the majority quorum agrees. So even if there is a network issue or a hardware failure, data consistency is protected always. So CPH avoids this by not allowing any map updates without strict majority. So it is the thing for the PAXOS and quorum. So let me give you a short recap. So Mons use PAXOS to agree safely. Quorum is required to keep the system running properly, and without it, Ceph protects your data by locking down changes. So in a Ceph cluster, it's not enough to just have Mons online. You need a majority of them healthy and talking to each other at all times. Okay, so as you can see in this image, if the number of Mons is 1, then the quorum requirement is no redundancy. It's normally not recommended. If the number of Mons is 3, then the quorum requirement is 2 for quorum. So here you can say design rule is always use the odd numbers greater than equal to 3. Okay. So if it is 5, then it is for 3 for quorum, and if it is 7, then it is obviously 4 for the quorum. So if it will be 9, then it will be 5 for the quorum. Okay, and it will be goes on. So it is the final Mon slide, that is Mon's architecture and best practices. So all right, let's now bring everything together. We have learned what Mons do, the maps they manage, and how they reach agreement using quorum and PAXOS. Now let's talk about how to design Mons properly and what to do if things goes wrong. Mons deployment best practices. Here are the few rules that every CPH admin, okay, should follow when deploying the Mons. So always deploy Mons on a different physical nodes. So don't put all Mons on the same server. No, one failure could bring them all down. So we will see in the upcoming video, sir, that how I am going to deploy the Mon on the different nodes. Okay, so if one node fails, then the two or the rest nodes will keep it working. Okay, so then use always stable, low latency network connections between Mons. The faster and most reliable their communication, the healthier your cluster. So for making the healthier cluster, you have to always ensure that the communication between the each Mons should be faster and reliable. Then we have to keep the Mons protected. Use firewalls. Don't expose your Mons port to the public. It always try to keep it to private. Okay. So Mons hold sensitive cluster and the control data. Then backup Mon data periodically. So it is the normally the command we will use. Sorry, it's the command we will be using to backup to recover in case of any failure. So if Mon failure, so if a Mon fails, so don't be panic. CPH can still run as the quorum is maintained. Then to recover, we have to restarting or we'll try to restarting the Mons process, and it is the command systemctl restart Ceph mon the ID. So ID means if we have three different clusters, so each cluster should have at least one monitor. So every cluster have something ID like mon ID 1 or ID 2, ID 3, it will be replaced by that. Then if the mon is completely dead, you can remove it from the Mon map and redeploy it on a healthy node. So, but again, if you have three Mons and two are down, there's no quorum. Your cluster becomes read only mode only. Then Mon security with Ceph. So CPH uses Ceph for secure communication between components. Mons issue and verify auth keys for clients, OSDs, MGRs, managers. So Mons are not just map keepers, they're also the gatekeepers of the security. So for a quick recap, Mons must be placed carefully and monitored regularly. Always maintain an odd number, as I said. Okay, like this, you have to always maintain an odd number and it should be greater than equal to 3. Losing quorum, that means losing your write access. It will be only work on read only mode only. So then the Mons protect both cluster state and access control. Okay, so that's everything you need to know about Mons, and the you can say the Mon the brain of CPH. And this is for the day 2, and thank you so much for joining us, joining me. And if you have any doubt or any questions, you can directly comment me. I'll be happy to answer them all. And in the day 3, we will be moving to the next main component, that is the managers or the MGRs, the part of the CPS that gives us dashboard, metrics, and the smart automation. So so let's meet in the day 3, and thank you everyone. Thank you all. Jai Jagannath.